Okay, gang. Here's your second problem of the day. This one's kind of fun. All right. So go ahead and hit pause if you want to read it, but I'll read it with you. A printer wants to make a poster that will have 24 square inches of print. The margins at the top and the bottom will be 1.5 inches. The margins on the sides need to be 1 inch. What dimensions would use the least amount of paper? Okay. So let's mix this up. Let's draw a picture. Okay. All right, and now here's the weird part. This has got the print in it, right? And that's good. Whoa, sorry. And that's going to have 24 square inches. So we got to label this. There's a couple ways to label this. You can either label the printed area or you can label the dimensions of the paper. I'm going to label the printed area. So I'm going to call this X and this Y. All right. So I'm going to start this time by getting my secondary equation. There's my secondary equation. All right. So I still need a primary equation because that's what I'm trying to optimize. So if I can correctly read, I got a margin here of 1 and a margin here of 1.5. So what are the dimensions of the paper? Well, let's go sideways. From here to here, right? This is X. And then I got an inch on the right, an inch on the left. So that gives me X plus 2. So we'll call this area of the paper. And now what about the other dimension? Well, from here to here is Y, and I got an inch and a half on the top and the bottom, so that's going to be Y plus 3. Okay? Now, there's a couple ways to do this. Like I said, we could label it differently, but from this point on, there's a couple of ways. You could multiply this you can multiply this part out, right? Do your foiling, all right? I'm not sure I would recommend that. So, but I have too many variables. So let's come over here. Y equals 24 over X. That's a pretty easy algebra problem, right? So here we go. I still have my X plus 2. And now instead of Y, I'm going to plug in 24 over X plus 3. Now I feel that I should multiply this out. Okay, so we'll just move this up over here, save me some space. X times 24 over X is just 24. Right? And X times 3 is 3X. And now I have this guy, which is 48 over X. And then the last part is 6. I think I can put some things together that go together. We'll come over here. Area equals 24 and 6 is 30 plus 3x, sorry about that, 3x. And the last one is 48 over x. I know I'm going to have to take derivative, and I don't want to have to use a quotient rule. That just doesn't make any sense to me. So I'm going to write it that way. Okay? All right. Next step, take the derivative. Derivative of 30 is 0. The derivative of 3x is 3. And now the derivative of 48x to the negative first is negative 48, x to the negative second. Don't like that. Let's rewrite it. 48 over x squared. And our next step is to set my derivative equal to 0 to get a critical number. So I set this equal to 0. My algebra takes me over to here. 48 over x squared. Favorite thing every high school mathematician wants to do is cross multiply. So I get 3x squared equals 48. Divide by 3, I get this. So I get x equals positive or negative 4, but we're talking about a dimension of a piece of paper, so that negative 4 makes no sense. So we're going to go with x equals 4. And remember what we said earlier, it always gives you the right answer. This one we were looking for a minimum, and we still got the right answer. Previous problems we were looking for maximums. So I know x equals 4. Now take this, plug it back into here, and I get y equals 24 over 4, or y equals 6. So the dimensions of the paper would be 4 by 6 inches. Always remember your units. Okay, so there's your second optimization example of the day. Hopefully that made a little sense. If not, give me a holler.